This section on the C3 mind map is related to batch and continuous processes. Okay, batch and continuous processes are methods in which chemicals can actually be made. They are very, very different in what they generally produce, and they're very, very different in the advantages and disadvantages, and they're very, very different when it comes to the kind of processes actually that are involved. In the case of batch processes are where you basically want to produce small amounts. So you might want to produce one chemical, and then you might want to change that chemical and produce a different chemical. It could be, for example, producing winter vaccines, okay, so for things like flu, where you don't want to actually create large amounts and on a continuous basis. You actually want to create a little bit that may go and be stored for a period of time, then you might want to produce some more a bit later. So it tends to be linking to pharmaceutical drugs, okay, basically medicines, okay, in particular. So you produce a little bit and then you produce a little bit more maybe later, you produce a different chemical in between. When it comes to continuous, you're generally talking about kind of key chemicals. So you're talking about things like ammonia production, for example. So you're looking at chemical production. And in the case, just like you'd expect from the name, continuous, as in ongoing, what we're actually looking at is we're looking at chemicals that are produced over a very, very, very long period of time, okay? Basically, it's produced all the time. So we're talking about large amounts, and we're talking about continuous production, okay? The processing plants don't actually stop. So let's have a look at batch kind of to start with, okay, we're looking at small amounts being produced. You're looking at examples like medicines, okay, so vaccines, for example, maybe things like ibuprofen, things like paracetamol, things that maybe not bought on a regular basis, so you don't want to keep on producing lots and lots and lots. There are lots of good things and there are bad things, okay, when it comes to batch processes. So let's have a look at the positive things to start with. There are two real kind of key positives to using a batch process. That's the fact that, as I was saying, you can change, okay, so you can make more than one chemical. So that is definitely a positive side to this. And the other thing is that the equipment that is being used tends to be a lower cost. So again, two real positive things, okay. But like with everything, there are disadvantages, there are negatives. And when it comes to batch, it's very, very difficult to automate. Now, what automate means is for your system to basically be run using the machinery. Okay, this tends to need a much bigger workforce. So you actually need people. Okay, and obviously, if you need more people, you have obviously got the disadvantage of the fact that you have to pay them. Okay, so looking at the workforce, you're looking at something that makes it potentially a little bit more expensive. So the setup cost, the equipment is lower, but the actual running cost is actually a lot more expensive. You also get quite a low rate of production. So you don't actually make that much chemical, okay? And that can be a disadvantage if you need to increase how much you're actually producing. So the production rate is actually quite low. And when you get to a point when you have to obviously change, okay, chemicals, you have to make sure that your reaction vessel is cleaned, you have to have shutdown time. And shutdown time is a negative for industry because you are still employing people, you're not producing the chemicals that you're trying to produce, like your pharmaceutical drugs, your medicines. And that actually happens quite often, especially if you're making more than one chemical. So there are definite advantages and disadvantages to using a batch process, and that goes exactly the same for a continuous process where you are producing much larger amounts, okay, of your chemicals. So in terms of advantages, because of the fact that you have got continuous production in large amounts, that never really stops, okay, so basically shutdown time is really, really rare, okay, very, very rare. It's very easy to automate. You can use computers, you can use machinery. Okay, and that is obviously a good thing because the fact that you have a lower workforce, you don't have to actually pay as many people in your industry. Another good thing is that the rate of production of your chemical is actually very, very high. Okay, so it has a high production rate. Again, just like with, let me just put in fewer people there, just like with batch, you have got some definite negatives, and those disadvantages tend to be the setup costs in particular. The equipment cost is high, which is a negative for setting it up in the first place, and also you can only make one chemical. Okay, so an ammonia plant will just basically make ammonia. Okay, so that's a good example. So when it comes to batching continuous, in terms of making things like pharmaceutical drugs and making things like our larger volumes like ammonia, there are definitely good things and there are bad things, okay, in both of them. Now, one thing that a lot of industry needs to do, in particular when it comes to pharmaceuticals, is that you have to extract chemicals. And to make a lot of pharmaceuticals, the chemicals that we tend to initially find tend to come from plant matter. So extracting chemicals from plants is an important part of the pharmaceutical industry. In the case of extraction of plant matter, there are stages that it has to go through. So the first thing is that the plant matter is crushed. Okay, so that's literally all that plant matter broken down. You then have boiling and dissolving in a suitable solvent. Now, solvent, if you remember, is just a liquid that something will dissolve into. Okay, so you need something that is suitable for the plant matter that you are actually investigating. You can use something like chromatography to separate the extracted chemicals. Chromatography is where you have the chemical that you're investigating, a solvent that allows the pigment or whatever the chemical is in the plant to be drawn upwards through a piece of filter paper or a piece of chromatography paper. And as the chemical that you are investigating moves upwards, it separates into areas. And that gives you the ability to extract and to separate the different chemicals that have been extracted. And those different places on the chromatography paper indicate completely different chemicals within that particular sample. Now, chromatography is something that can be used to test for purity. If something is completely pure and that sample has nothing else apart from one chemical within it, you would expect to only see one spot in one of those positions. So if we were looking at this as an example of testing for purity, you can see that this sample has broken down to 4 spots. That tells us there are 4 chemicals there, so it's not pure at all. Another way of testing for purity is melting point. So you can obviously use chromatography, but you can also use the melting point of your substance. The melting point of a pure substance should be very close to the real melting point of the substance. If it's slightly different, it basically means that the substance is slightly impure, okay, but it can't be significantly different. If it's significantly different, then it's going to be a different chemical. So in case of purity and melting point, you might have a pure substance, for example, that has a melting point of, let's say, 140 degrees Celsius. The sample that you have collected has a melting point of 139 degrees Celsius. That would be close enough to say it's probably the chemical, but it's a little bit impure. If your sample, okay, was actually 150 degrees Celsius, you would probably be looking at a different chemical, and potentially you don't have the chemical that you think that you do have.